So, thank you very much, everybody, for coming. My name is Josefine. I'm the Technical Officer here at Organic Ltd. We're very excited to welcome you to the first of our 2022 Climate Change Series. This is just the general introduction. After this, we will be going sector by sector, delving deep into what you can do as a producer if you're in that sector, what you can do as a consumer in that sector, and get a better understanding of what climate change means for the agricultural industry and especially the organic industry specifically. So this first webinar is free for all as such, but as we delve deeper, it will only be for Bud licensees and AOL members. So if you aren't already, please contact Marie, our memberships executive, and she can definitely help you with that. So we really wanted to introduce climate change and the most up-to-date peer-reviewed predictions for the future of the climate, depending on our actions as a whole industry. We have some world-class speakers here for you today. The first one is Professor Mark Howden. So he joins us most graciously after spending half the night awake with Europe because he is the Vice Chair of the Intergovernmental Panel on Climate Change. He is also the Director for the Climate, Energy and Disaster Solutions at the Australian National University. His record is immaculate and he's got over 30 plus years of experience within the climate change sector. We also have Dr. Lynette Beatio, and she's a senior climatologist at the Bureau of Meteorology. She's the one who's responsible for the preparation and analysis of Australia's climate records, the long-term records. You know, what you potentially see on the BOM is definitely coming from her department. So she will be giving us better insight into, you know, the tools that you can have as a farmer, producer, anybody to understand the weather prognosis better. So at any time, you know, please type your questions into the box and I will ask Mark and Lynette on your behalf at the end of the webinar. We will be recording the presentation and the slides, so there might be quite a bit of technical information here, so please don't stress about taking notes. You'll be getting the recording and the slides via email tomorrow or the day after that. And we really want you to understand that sustainability is the core of the organic industry. And it is only through understanding where our main emissions come from that we can collectively work as an industry to minimise this. And it's really only understanding climate change that we can work as an industry and you know, from farmer to producer to consumer, and have better resilience towards climate change going forward. So climate change is something I'm very passionate about. I found myself in Svalbard, middle of nowhere, 78 degrees north, studying climate change at university. Now, Svalbard is a unique place. You might have seen it from David Attenborough's Frozen Planet. However, it is extremely affected by climate change. If it's through the melting ice sheets, the photos of the starving polar bears, you know, the rain on snow events that potentially kill the reindeer, it was very much a case where the weather was changing at an extreme rate, and I found myself asking, okay, well, what can we as humans do to prevent this from ensuing further? This led me to organic agriculture as such. So after the ocean, soil is the largest carbon sink on Earth, and Australian farmers manage 51% of the Australian landscape. And the history of this is not so positive. Most agricultural soils have lost between 30 to 75% of their original organic soil carbon ratios as such. And this is mostly due to unsustainable agricultural practices. So the most well-known long-term conventional versus organic study is at the Rodale Institute. This has gone on for over 30 years, and within their last report, their 30-year report, they found that organic systems emit 40% less greenhouse gas emissions. They have 40% higher yields in times of drought, and if the whole world, or all the agriculture in the world, were to switch to a more sustainable form of organic management practice, then we could currently sequester more than 100% of the current annual carbon dioxide emissions, which is something very interesting. You know, as an industry, what does this mean for the rest of agriculture in Australia? So if we look at then climate change in Australia, extreme weather events already cost Australian farms on average $30,000. And with the inflation, you know, this statistic is from 2021. I'm sure that that's already doubled by now. I think we're very quick to forget the Black Summer bushfires. They burned 24 million hectares. So this is equivalent to the size of the UK. It's larger than most countries on the planet Earth. That is what burned in Australia in that 2019-2020 period. And there's many things that we can do to potentially minimise the chance of that happening again. So if we look at the current predictions, you know, Australian land areas, they've warmed 1.4 degrees, and this is well above the global average of 1 degree for the same period. And so what does this mean for organic agriculture? So all the blood, sweat, tears, all the hard work of farmers, you know, it all comes down to this graph. This is the Department of Industry's quarterly update of Australia's national greenhouse gas inventory, and agriculture accounted for nearly 15% of that. Most of this, you know, is through the enteric methane emissions from livestock, but it is still a sizable amount, and the Australian the governmental climate policy puts a lot of pressure on the agricultural industry going forward in terms of greenhouse gas emissions mitigation. So if we look at what that actually means, yes, livestock is a huge part of that, but there are also other areas within the agricultural sector where we can definitely improve. So for the producers out there, at no point will I tell you what to do. At the end of the day, you know your farm a lot better than what I ever will. I want to present to you the peer-reviewed scientific literature. I invite you to question your current production systems today and throughout this webinar series. You know, is your production system as resilient as possible? And what are some of the small changes that you can make to improve your current system, and what will you do with the information that we present to you here today? So you can see, you know, 1% increase in soil organic matter, it just, the water holding capacity increases so much, and the same with the carbon, and even bare ground, you know, in terms of the temperature difference between bare ground and covered ground with grass or other shrubs makes a huge difference. And I'd love for you to keep these facts in mind as I introduce to you Professor Mark Howard. So thank you very much, Mark, for being here today. We have your lovely slides here if you're there. If you wouldn't mind coming off mute and introducing the climate series to what this actually means. What are the long-term future predictions for the weather in Australia, and how will that affect our producers?
Well, thanks very much, Josefine, for the opportunity to speak here today. And I'm just giving a very quick coverage of what's an incredibly complex topic, and so it will necessarily be fairly brief and you know, not delving into the depths of it. But I guess the question I'm asking is about climate change and the future of Australian organic agriculture, and you know, where are we heading with this? You know, are we heading into the storm? Are we heading towards a rainbow, or is it a sunset? And that we're heading to. And so that's the sort of thing that I just trying to explore here. If we go to the next slide. So the first thing I'd make is that our greenhouse gas emissions across the globe are increasing significantly. So we've got the graph here. Excuse the dog in the background. I'll just go and deal with the dog for a sec. Just hold on.
It sounds like a good guard dog. So in the chat today, we've got some lovely people joining us. And as I said previously, at any time, his graphs are amazing, but they are quite technical. So at any time, if you don't understand anything Mark is presenting, please write the question in the chat or the question answers, and I'll be very happy to prompt him for those. We got another webinar participant.
So sorry about that. So I'll just keep going if that's okay, Josephine. So the first point I make is just that our greenhouse gas emissions, in this case carbon dioxide from industrial type sources, keeps on growing at a global level. Had a bit of a dip at the COVID period, just like we had a temporary dip with the global financial crisis going back some time. And the problem here is that to actually solve climate change, it's not about leveling off this graph, it's actually about taking it down to zero. So going from 36 billion tonnes a year, and we have to take that down to zero for carbon dioxide. And because what happens with this carbon dioxide is that some of it is absorbed by the soil and the trees and the grass and the oceans, but a significant proportion of it, around about half, actually keeps in the atmosphere, and it stays in the atmosphere for decades to hundreds of years. And as a result of what we're doing in terms of carbon dioxide, we've already increased the concentration in the atmosphere from around about 280 parts per million pre-industrially down up to about 418 today. And so it's a 50% increase basically. And as well as record levels of carbon dioxide in the atmosphere, we've got record levels of methane, nitrous oxide and other greenhouse gases. So these are things we haven't seen for millions of years in terms of the levels that we currently have. And if you look at methane, because that will come up later in the talk, we've effectively tripled the pre-industrial concentration of methane in the atmosphere. So these are really big changes that humans are doing. Next slide, please. And that sort of impact of greenhouse gases like carbon dioxide and methane is already warming the Earth. And that's what this graph shows. It separates out the best estimate of what the natural variation would have been in terms of temperature, going back to the 1850s, and then compares it with what happens when you add in the human influence through things like greenhouse gas emissions. And we can see that when we add in the human influence, we actually get a very significant rise in temperature, which you just don't get if it's only the natural variations from solar variation and volcanic activity, etc. And what we're seeing with the best estimate modelled human plus natural, it tallies very closely with the observed. So we're very confident that now the human fingerprint on climate change is now unequivocal. It's incontrovertible. It's simply a statement of fact. This is not up for debate any longer. So if we move to the next slide. So these sorts of temperatures, along with rainfall changes and changes in evaporation, so that's essentially the dryness of the air, have already resulted in very significant impacts on agricultural productivity here in Australia and also globally. So this is a pretty recent study which actually just looks at that, and you can see what this analysis shows, which uses actual agricultural statistics, not modelled information. But when this analysis tries to take out the improvement from technology and management and separates that out from the change due to climate, what we find is that climate influence is really negative in almost all countries, with the exception of, say, Canada and the old USSR. And so Australia, our agricultural productivity, essentially in the absence of climate change, would have been about 20% higher than what we're observing. And that's actually where the global average is, about 21% higher. But we can see that Australia is badly affected, but there's other countries which are much more badly affected than we are, particularly through Africa, Central America, and parts of Southeast Asia. So we don't have to wait for agriculture to be affected by climate change. It's very, very clear that that's happening right now, and it's really big. Like, this is a really non-trivial impact. Right now, like in the 2020s, this is not a 2050 scenario. This is actually what's already happened in terms of agricultural productivity. So next slide. So when we look at that sort of picture of greenhouse gases, the first slide that I showed you was essentially the fossil fuel-based and industrial type activities, such as, you know, concrete manufacture, that sort of thing. But agriculture has a big part to play in greenhouse gases, and Josefine's already mentioned this through the Australian Greenhouse Gas Inventory. And so, but when we look at the whole of the food system, there's actually a lot of greenhouse gases which aren't included in that number that Josefine just put up there. So, for example, that number just includes the direct methane and nitrous oxide and sometimes carbon consequences of agriculture. But it doesn't deal with the other elements, such as, you know, what are the emissions associated with inputs into the farm, and what are the emissions associated with the transport and processing and storage and retailing of those farm products. And when you add all of those up, food systems are around about 29%. So you could just say almost a third of global greenhouse gas emissions. So that's across the value chain. And if we just look at the agricultural and land use change component of that, it's still around about 23%. So, you know, a quarter of the global emissions, and the Australian numbers aren't that far off when you actually do the adding up of the different components. So when you're dealing with, you know, a quarter to a third of emissions, it's way, way too big to ignore. At the moment, we've largely ignored that because everyone, well, the politicians are focused on, you know, solar panels versus coal-fired power stations sort of stuff. But in fact, that there's a lot of other greenhouse gas emissions. So our electricity system produces around about 30% of Australia's greenhouse gas emissions, which means that 70% is not in our electricity system, yet you never hear about it. And that's why these sorts of discussions are really important, because it actually raises the topic of what about the other components. So next slide. So the question with climate change is, you know, where are we going to head? What are the choices that we make now that are going to influence our future climate and hence future agriculture and consumption patterns and various other things? And this is a graph that came out of the IPCC Working Group 1 report late last year. And what this just shows is different levels of carbon dioxide emissions, and which may occur, different scenarios, that's why I say may occur, over the next 100 years or so. And you can see that the consequences range from the really high temperatures, like 5 degrees more warming than pre-industrial, if we go on a very high scenario, down to about 1.5 degrees if we go down on a very low greenhouse gas emissions scenario. And those temperatures, just to put them in context, 5 degrees is roughly the difference between the previous ice age and our historical temperatures. So, you know, 5 degrees is an ice age worth of temperature change, but in this case, in the opposite direction. So it's a really, really non-trivial number, just like where we are now, which is about 1.24 degrees globally, is a really non-trivial number, even though it mightn't sound much. So it's essentially a quarter of an ice age's temperature change that we've already seen as a result of human greenhouse gas emissions. And even if everyone does what they said they'd do under the Paris Agreement and the Glasgow Agreement, we'd still end up getting close to 3 degrees Celsius hotter than pre-industrial. So you know, we're not heading in a happy place at the moment, because Australia is going to get the raw end of this deal. But if we go to the next slide, one of the things that people tend to, oh, actually go back one, Josefine. One of the things that I point out here is if we go on the low or very low emissions, which are consistent with Paris Agreement temperature goals, like 1.5 to 2 degrees higher than pre-industrial, in both cases, we actually have to go below the line. We not only have to reduce carbon dioxide down to zero, then we have to start sucking it out of the atmosphere. And of course, agriculture is one way of sucking carbon dioxide out of the atmosphere, not the only way, but it's one way of doing that. So if we go to the next slide. But when we're dealing with agriculture, quite a bit of the emissions are associated with methane and nitrous oxide. And these are the two panels on the right. And they're exactly the same as the carbon dioxide panels, same colour scheme, etc. But what that shows is if we want to go to those lower temperature changes, the low to very low scenarios, in the case of methane, we don't have to take that down to zero, but we do have to reduce it by about 60%. So if people talk about going to zero for methane, that's actually not necessary to actually keep temperatures to 1.5 or 2 degrees. And similarly with nitrous oxide, you don't have to take that to zero. What you just have to do is take about 20% out of your system. So of course, those numbers will go up or down depending on how much you juggle the carbon dioxide numbers. So it's a part of a package. So if you go harder on the carbon dioxide, you can go easier on the methane, nitrous oxide, and vice versa. But these as sort of general scenarios, I think are really important because it's the message that you don't have to go to zero for methane and nitrous oxide, which are the key gases from agriculture. Now, if we go to the next slide, the next slide is just about 3 slides on what the future might look like in terms of the physical climate changes. So these are 2 panels from that working group, IPCC Working Group 1 report. The left-hand panel is the temperature increase, what it would look like at a 4 degree scenario, so a little bit higher than where we're currently heading, and what the rainfall would look like at 4 degrees. So the patterns for lower temperatures like 2 degrees are essentially exactly the same, but the colours just aren't as intense, the temperature change isn't quite as much. But under these sorts of scenarios, which is pretty much sort of where we're heading at the moment, there's going to be really significant health-related issues. Heat stress, vector and waterborne disease, foodborne disease is increasing because, as temperature goes up, your bacteria multiply more quickly, and so you get more food disease. Rainfall variability is likely to increase significantly, in part because of likely increases in the driven by the El Nino, La Nina. So we're already starting to see that come in. So the droughts are harder and the wet years are wetter than they used to be. So we get more droughts and more floods at the same time with climate change. Well, not at the same time, but as a consequence of climate change. Big implications, as I'll show you, in terms of water availability. And of course, there's massive implications in terms of fires and similar extremes. One of the things that people don't tend to talk about is that climate change is almost guaranteed to bring increased rainfall intensity. So as the atmosphere warms up, it can hold exponentially more water. That means that when it rains, it tends to rain in bigger buckets and it dumps harder. And that has consequences for erosion. And so, the value of having good ground cover increases significantly under those scenarios. So the bare ground is actually really problematic in those circumstances, not just for the temperature change that Josefine mentioned before. Obviously, there's implications in all sorts of other things with rainfall intensity, infrastructure damage and other things. Higher temperatures are going to drive up the sea level, not only because warmer oceans are deeper oceans, the water expands as it warms up, but also melting of things like the Greenland ice cap and increasingly the Antarctic ice, as well as melting of glaciers. And so we're likely to see that sea level rise going up significantly. And if you combine that sea level rise with things like stronger cyclones, we're already seeing an increased proportion of cyclones being the strong ones, the category 3, 4, and 5 ones. That means you're going to get increased flooding and storm surge events around our coasts. And often there's very productive agriculture around our coastlines. And the last point that I make is compound events. So these things don't happen in isolation. So for example, if you think back to Black Summer, we had extreme drought, we had extreme lack of water on our landscape, so extremely dry soils, and we had extreme heat and we had extreme fires. So it's not just one thing, it's multiple things together that's actually the problem here. So if we go to the next, and lastly, just rainfall. Depending on where you are, you could get really different outcomes in terms of rainfall. So Some places like the Arctic and the Antarctic and the equatorial Pacific are likely to significantly increase in rainfall, but many other parts of the world, including Australia, are likely to significantly decrease. So those trends that we've already been seeing in southern Australia continue out into the future. Next slide. As a result of higher temperatures, in many cases less rainfall and higher evaporation rates, potential evaporation rates, we're likely to see increases in drought in many places. And so obviously that has implications for food production, and that increased variability means that the demand, particularly in developing countries, for food will become very highly variable. And so that means trade is likely to increase. So because some places won't have enough food on a more frequent basis, prices are likely to increase because demand is going up, but supply will become more variable, in some places going down as well. And so one of the key messages here is that there's going to be increasingly a competitive advantage to those who adapt best to the emerging climate impacts, including drought. So, and I say this because it ties back into what Josefine said before, which is if you have something like an organic agriculture system with good ground cover, good soil moisture conservation, it's less affected by drought. So you can continue to maintain at least some productivity under circumstances where less well-managed systems don't have any productivity. So next slide. And of course, water is crucial in a place like Australia. And what we're seeing already is our land of droughts and flooding rains, as epitomised in this graph of Murray-Darling Basin flows. It's the Murray flows. Obviously, it's always been variable, and it will continue to be variable and possibly even more variable. But what we've seen already over the last couple of decades is a reduction in the average flows across the Murray-Darling Basin. I'll just have to de-toy the dog. And the sort of triangle to the right is the projected changes in average flows for the Murray. And one of the really important things from this diagram is that you can see that the reduction in flows, where we're down in the last 20 years or so, we're hanging around about 7,000 gigalitres a year, down from about 11,000, the long-term historical, is that sort of level of average flow we've experienced in the last 2 decades is actually the worst case scenario in 2050, according to these model results. So the message here from me is that it's very easy to underestimate the implications of climate change. Even the worst case scenarios in the future may actually be better than things may pan out. So really important to take this seriously. The next slide. So I've got just, I think, 2 slides after this, but just pointing out that when we actually look at a global scale, we've got sort of overlapping and nested goals. We obviously want to have food security at a global scale, and even in a place like Australia, there are people who are food insecure in Australia. We want to adapt to the climate of the future, so dealing with climate variability and the changes in variability and in averages that we're already seeing and likely to see more of. And at the same time, we want to reduce our greenhouse gas emissions. And all of that sits within a much bigger question about how do we actually have a sustainable population and sustainable consumption patterns across the globe. And so there's nested sort of issues here, and climate change is just one part of those nested issues. So if we go to the next slide, it's just a slide which talks about how do we adapt agriculture to a changing climate. So for starters, I'd point out that it's really highly contextual. So it very much depends on the values of the farmers and also of the consumers that are using those products. So, and the reason why I mention this is those values could well differ between an organic producer versus a conventional producer of a similar commodity or a similar product. Secondly, is that we know from our past experience and analysis that there's a huge variety of adaptation options available in the agriculture sector. So you can have on-farm options and off-farm options. diversification, which is probably important for you. And there's short-term and long-term, small scale to big scale change. Transformational scale is the big scale. And then there's all sorts of changes that can happen at an institutional or regional level. You're a pain, dog, you're a pain. Yeah, I'm going to put that up there. Sorry, the dog hasn't learned meeting protocol yet. So all of these changes involve some degree of costs and changes in knowledge, but they're always done because you think you'll be better off than you would otherwise be. And that's, in a sense, the silver lining around the climate change cloud, is that, effective adaptation gives you a comparative advantage and it makes you better off than you would otherwise be. And what various studies have shown that we've done is that dealing with climate change actually empowers people and gives a sense of control, often in a sort of almost out of control environment. And through that reduces stress of people, so they feel better, that they're healthier farmers, mentally and physically. But this isn't a rose-coloured sort of view of things. There are limits to how well agriculture can adapt in any given location or any given system. There's barriers to adaptation, so things that stop people from going down that pathway. And there's a need to integrate adaptation with mitigation. So when we're thinking about soil carbon, for example, we have to think about a hotter and drier future, which by itself will drive down soil carbon levels. So we need to be very realistic about what we are thinking about here. And the last slide, Josefine, is just on emission reduction options. And again, without going into detail, because that will be covered in later talks, but some of the obvious things is improved on-farm management. So if you've got an inefficient system, tightening up that system means that you will often save money as well as produce less greenhouse gas emissions. There are ways of reducing direct greenhouse gas emissions. So for example, there are products now which you can feed livestock which reduce emissions by about 30% or so. So there's a product just coming on the market called Bovea from Europe, which does that. But it's only for reasonably intensively farmed animals, not extensively farmed animals, so animals with long distances to go to feed. Of course, there's a lot of talk about increasing soil carbon and biomass carbon on our landscapes, and that's generally speaking a pretty good thing. There's a lot to be said that's positive about having higher levels of soil carbon. So you have soil which has better water infiltration, better water holding capacity, and better nutrient delivery to those plants at the time the plants need it. But you can only increase soil carbon where there's two possible options there. One is where you have increased inputs of carbon into your system, so more growth, which actually pushes more carbon into your soil system, or where you reduce your decomposition of soil carbon in the soil. And now that might sound like a good thing, but when soil carbon decomposes, it releases the nitrogen and phosphorus and potassium and sulfur that's associated with it, and it makes that available for plants. So decomposition of soil carbon is part of our agricultural systems, whether it's organic or conventional. And so when we think about soil carbon increase, you can't separate it from the dynamics of what happens with phosphorus and potassium and sulfur and other nutrients. And these are really non-trivial numbers. So for example, if you want to, and I should have added nitrogen in there too, if you want to store a ton of carbon in your soil, at the same time, you've got to store something like 100 kilos of nitrogen and something like about 10 to 15 kilos of phosphorus, etc. So these are not separate things, they are intimately linked. You can't separate them out. There's obviously, in terms of emission reductions, improving value chain efficiency. So, lower greenhouse gas emission packaging and transport. So as electric vehicles come on stream, going instead of diesel trucks, electric trucks with renewables, etc. So all those ways of pushing down the emissions. There's broader system changes that can occur, such as dietary change, moving people away from meats, particularly high emission meats. Red meats in particular have high emissions per product. And reducing food loss and waste. So ensuring you don't throw out, marked fruit that it actually is able to use something. people being responsible so they don't have lots of fruit that goes off in the fridge or veggies that go off in the fridge, that sort of thing. So just pushing down on all of that loss and waste that's in our system, which is really substantial, estimates of around about 30%. And lastly, it's about how do you integrate something like organic agriculture with things like solar photovoltaics or wind farming, so energy farming on your land, or BECCS, which is biochar plus energy systems, basically, and thinking about how you can actually integrate those things to make your farm not only environmentally friendly or even more environmentally friendly and sustainable, but profitable, and a showcase for how other people can do this and go down a pathway which actually leads to a much better future. So I'll just leave it there, Josefine, and happy to answer questions later.
There we go, sorry. Thank you very much, Mark, for that and the incredible insight on the situation. Like I said, we will be sharing this recording and the slides, and you always have such amazing interpretation of the results and making it more applicable to us as the organic agricultural industry. So we've heard the long-term predictions of climate change. However, how does this affect producers more in the short term? So I invite Dr. Lynette Meteo to tell us more about current tools available for you at BOM and how you can use these to increase efficiency for short, medium-term climatic predictions for your farming systems. And without further ado, I'll hand over to you, Lynette.
Thanks, Josephine. So, yeah, very happy to be here today to talk about the tools that we have at the Bureau and at CSIRO for exploring our changing climate. And just like to thank Josephine for organising this, and also thank Mark for a wonderful presentation as always. So, if you just go to the next slide, please, Josephine. So as Mark said, why is this something we're interested in? Well, we're interested in because it's actually something that's impacting us, and it's not something that's going to impact us way in the future that we might have to think about and perhaps, plan for, but it's actually something that's impacting us now, globally and in Australia. So this is from the Bureau and CSIRO State of the Climate Report, and if you haven't read that, I recommend going to have a look at that. But just showing in the top left-hand corner there, just what we've seen during the last 20 years, that the rainfall over that April to October, so that important growing season for southern Australia, has declined. And as Mark said, looking at that bottom graph, you can see that there's large variability in that signal. So whilst there is large variability, you can see towards the end of the graph, that right-hand side there, we can see a trend coming out or a change happening. We can see that we have much more drier than average years compared to those wet years or really wet years. And so what we're seeing is some of those really intense drought years or dry years, and we're not seeing those recovery years. We're not seeing those really wet years where the systems and the environment can recover. So really important that we're not just looking at those changing averages, that we're keeping in mind how is my variability changing as well. And then on the right-hand side, just a general picture of some of, as Mark has gone through, some of the things that we are seeing now, and we will continue to see into the future with climate change. And just wanted to make the point too that all this information, all this data, this is what underpins, if you go to the next slide, please. This is what underpins a new service called Climate Services for Agriculture. So this is the Bureau and CSIRO joining forces to provide this service. And I've circled a couple of things here, and I just want to focus on that top circle at the moment. So really important, And please, if you go to this website and have a look, please provide your feedback, because this is an ongoing, it's not one of those, it's not one of those websites where we put it out and say, here you go. It's one of those ones that we want to keep creating, that we want to take your feedback on how we can make it better for you, how we can make it more useful for you, and change it so it is. So this website will be continuing to develop, and so your feedback is crucial to that. It's one of the main aims of the project, to go out, to talk to agricultural producers such as yourself, get that feedback, bring it back and take it on board and change what we do. So it's got a couple of aspects to the website. One of the main aim is that past and future climate. So thinking about how has my climate risk changed at my location. So it's a location-based service. I've put Wangaratta there because that's one of the regions where I grew up. So how has it changed in my location, and how is it likely to change in the future? So that changing risk. And we also have in there a seasonal forecast, again using the Bureau seasonal forecast services, but trying to communicate it in a way that might be more applicable to how agricultural users can use that service in their decision making. So if you go to the next slide, please. So if you click on past and future climate, this is what you'll get. So just starting on the left-hand side there, where I've got it circled, you can see you can choose a time period, and you can choose a medium or high emission scenario. And as Mark said, there's a number of scenarios that, pathways that we're there is a pathway that we're currently on. There's a number of scenarios of how this might change in the future. And really just wanted to include two scenarios here, because it can actually tell you a lot of useful information. It can tell you by looking at the comparison how sensitive your location might be to climate variability or climate change into the future. So if you click on those buttons, what will update is those squares, those tables in the middle there. So you'll get, I've clicked on here, it's just looking at the commodity is the general one for 2030 and for medium emissions. And looking at that, you'll see I've got autumn highlighted in blue. So I've clicked on autumn, but you'll see, you can see for autumn, well, you've got annual, autumn, winter, spring and summer. You can see, well, looking at my annual rainfall in Wangaratta from a historical period, 1961 to 1990, and a more recent period, 1991 to 2020, there has been a drop in annual rainfall. But if we actually drill down into that seasons, we can see that there has been a drop over autumn. So going from 150 millimetres averaged over that period for autumn to 120 millimetres averaged over the more recent period. And then looking at 2030, we see that the average of the model average of what the models are saying is going to be the model mean over a 30-year period centred on 2030 is actually very similar. So which I suppose gives confidence in the way with that, similar to that diagram that Mark showed us. It's showing that the direction of the change and into the future, but it's not going to change. It's not changing too much in this more recent period, but the direction of change is what we've actually seen in the observed record. So if you click on one of those squares in the middle, you'll get a graph like what you see up in the blue lines up in the right-hand corner there, with the 30-year averages superimposed on that lines. But again, what I want to show is that up is that up and down, that variability. So looking at those blue lines going up and down, so all rainfall for autumn over that period. And if you click on the button above it, you can download that graph, or you can download the data for your location. But you can see that it's actually going up and down. So again, there's a large range of variability there. And you can see again that there's more of those dry years compared to those wetter years. And then looking at the future autumn rainfall, so you don't actually have to worry about any clicks on the left-hand side for this one, because this graph doesn't change. You've got the medium emission scenario and a high emission scenario sitting next to each other. And you've also got the observed records sitting next to each other. So this is another reason why I really like this service, because it's one of the, well, not say one of the first, but one of the first on a national basis to actually have the observations and the outlooks together, which gives you the projections together, which actually gives you a lot of information. And again, it might give you more confidence in the direction of change, but it actually tells you what the change has been and what it will be in future compared to that observed record. So not dwelling too much on this, but looking at that, that high and medium emissions, and just comparing the darker shading there, which is the range of the model means over the 30-year period, and the lighter shading, which is the interannual variability. So there's a lot to unpick from this. You might just look at it and just have a bit of a glance as to what direction it's going. And this is rainfall, so it's not quite, there is a lot more variability, as Mark said, compared to something like a change in temperature, which we'll see on the next slide, but we won't go to yet. But really looking to understand, you might just be interested in that darker shading. What's that? What are the models saying are going to be my average difference for that 30-year period? But you might actually also be interested in, well, what is the model saying? What is that range of year-to-year variability, that larger range? Is that range, am I going to see some potentially some dry years, or some more extreme dry years and less extreme really wet years? So you can see in that first 30-year period in the blue there, that range was it went up a lot higher than what we're seeing in the models subsequently. So if you go to the next slide, please. And first of all, looking at the same graph, this is temperature. So you can see quite a larger signal in that, and quite a larger step change and a difference between the two emissions scenarios. But again, looking back at the left-hand side, where I've chosen medium emissions, but it doesn't matter for that temperature graph. So you're looking at the 2050, you can see that the medium emission scenario going out to 2050. And what I have done now, if you're looking under that map of Wangaratta, you can actually see commodity, and you can actually select a commodity. And again, if you don't see your commodity here, speak up. There might be something we can do, or there might be we might be able to direct you to one that might be similar, or give you some similar information to what you're after. But here I've selected southern sheep, and people have told us, well, rainfall is important to us, but also temperature is important to us. And we will be introducing more factors for some of these commodities as well. But again, just looking at that middle, those middle boxes for temperature, I've selected the summer average temperature. So how hot is it going to get? And just remembering too that we're talking about averages, so we're just talking about that potentially that summer average temperature. And as we know and as we've seen, that doesn't mean every day will just be a little bit hotter. That means we're going to have those really extreme hot days, that really extreme heat, as we've certainly seen in recent years. So by clicking on that, I update that graph with the blue lines in the top corner there, and I can see how that has increased over the past 60 years, but also looking at the graph below that, I can also see how that's increased over the past 60 years, but how it's projected to increase in the future, again, with that range of interannual variability compared to that model mean of the 30-year period. So going to the next slide, please. So we've talked a little bit about changing risk. And again, I'm going through quite quickly through these slides, and I know there's a lot to take in here, but so please do, if it's something you're interested in, please do contact the website or the project, because we're really really interested in having those deeper discussions on not only how to use it, but how you need to use it, or how you can best use it for you. So that changing climate, my climate is changing, my climate is going to change into the future. How can I manage that climate change, that changing climate? And one way we can do that is through the seasonal forecast. So this is the Bureau seasonal forecast, but repackaged, repurposed in a way that might be more useful for you for your decision making. So looking at the circles there, what do I have a high chance, what level of rainfall for the coming season, for that March to May season? And you can choose that first season or the first month from your time period. So looking at that green circle, what do I have a high chance of getting for the coming season? In Wangaratta, I have a high chance of getting 80 millimetres for the coming season, and I have a moderate chance of getting 127 millimetres. So moving beyond the circles there and breaking it down into the columns, again, looking at those columns and what do I have a chance of? I have 100% chance of getting it very small on my graph, sorry, but it looks like a possibly 28 millimetres. And so bringing in that climatology and bringing in that actual levels of rainfall and going through to I have a very, very slim chance of getting, you know, up into the 300 millimetres for the season. So, and then just on the left, just looking at, well, what is my median rainfall for that, for the period, for that March to May period, and what did I get last year, and also what have I had recently? So that really helps. We feel we've been told it really helps with the decision making if you know some of those recent conditions and some of those typical conditions. So if you go to the next slide, please. And I'm just aware we're getting short on time, but just again reinforcing that this actually comes from the Bureau. So you can always go to the Bureau website, and unfortunately from that link, if you click on the previous slide, well, if you're actually on the site and you click on the link to more information, where I've got circled there in red, climate outlooks, and if you go back to the next slide, it takes you to an about climate outlooks, and then you have to do a few more clicks, and I've shown you circled there where to click to actually get to the outlook. And it can actually give you more information too. So if you go to the next page, Josefine, we talk about that above and below median rainfall, but if you want to get a big picture of what's happening with Australia. If you want to get something beyond that, just that what's happening at my location, if you want to have a bit more confidence that this is actually a wider signal that we're seeing, you can, having a look at a map like this can actually give you perhaps that confidence, and actually having a look at the other information surrounding that. So I won't go too much into this because of time, but just noting that if you actually click on the map on the Bureau website, it will actually give you information as well for your location. And the pop-up is a little bit different now. It used to be what we saw on the Climate Services for Agriculture website, but now we break it down into the bins, into the 20% bins. So what is your probability of getting in the driest 20% or the wettest 20%, rather than just that above and below bins? So it does give you a little bit more information, and you can also look at the past accuracy as well. Next slide, please.
Yeah, you're just breaking up a little bit, Lynette.
Okay, so just next slide, please. Sorry. So what else can give you a little bit more confidence in the seasonal outlook and or a bit more information? So you might have heard we're currently in a La Nina event, and La Nina events typically mean increased rainfall over Australia. So if you have a forecast for increased chances of above median rainfall, and you're in the middle of a La Nina event, well, you might have more confidence in that forecast, in the skill of that forecast, and you might have more confidence too that that is going to be a sustained signal for a number of months, because La Nina does tend to last for a number of months. But we don't just have La Nina and El Nino acting on our climate, we have a number of other climate drivers as well. So which I've got pictured there, which we do have more information about in our outlooks and drivers section, where you can click on and watch videos on what's happened, how these drivers impact Australia, or keep up to date too fortnightly on our climate driver update, and that will tell you what the current state of drivers are and how that might impact rainfall over Australia. And that's something we're looking to introduce to the Climate Services for Agriculture website as well, to have some of that information on that. So next slide, please. And I've just got here, but what about the weekend? So just finishing up, you can go to the Water and the Land website on the Bureau's page, which was a website that was set up for to be aimed at agriculture. I will just say that this does not go through the forecasting experts. It's just purely based on a model consensus. So for the best forecast, do look at the forecast for your location through whatever service, through your app or the Bureau site or another app. But this can give you a bit of an idea of what's coming up, and you can also click on that site too to give you the chance of rainfall. So actually, again, well, what are the chances of getting those rainfall totals? So just, I think my next slide's my last one, and just in conclusion, so the Climate Services for Agriculture website, really looking at providing that nationally consistent picture, providing picture and information. So everyone around Australia can use the same information, can use the same tools to access information for their location. And how is my climate changing? How will it change into the future? And what tools do I have to manage my climate variability? And please do tell us your experience, because that will help shape the service going forward. And as I've said throughout, it is supported by data and science from the Bureau of Meteorology and CSIRO. So the data that you're seeing is the data that you'll see on those organisations as well. Thank you.
Thank you so much, Lynette. So we have gone a little bit over time, but if anybody wanted to send through any questions, we've gotten one question for Mark. If you could make the rules, what are the 3 things that you would change or enforce, rather?
Make the rules of what? I'm not quite sure.
I think that it would have to do with Australia, how Australia deals with climate change. You know, what would potentially be things that you would enforce?
Yeah, look, as a scientist, I'm not in the game of enforcement or telling people what to do, and I think you made this point too. But look, I think some constructive things that we could do is, firstly, just move on from the fake discussion we've had about uncertainties about climate change, and actually move on to dealing with it in a sensible and rational and evidence-based way. And what both myself and Lynette have been talking about is a step towards that. Secondly, I think it's about how do you, because there's many other things happening than climate change. So there's huge changes in our sort of technologies and in consumer demand and various other things. So the question is, how do you integrate effective responses to climate change with these other things that are going on? And the last one, if I had my choice, would be to actually say, well, let's be honest, we haven't got all of the tools in the toolkit or all of the answers or all of the technologies that we actually will need to deal with climate change in a constructive way. So let's put in place the research and development that actually gives us those options in the future so we can actually make good choices.
Yeah, definitely. And I think that those are very good non-specific but broad answers that we could definitely work towards. And thank you very much, Lynette. So, like I said, all the slides will be sent out to you. You will be able to access those direct links from Lynette's presentation. Also, if you are looking at the recording of this presentation, please don't hesitate to reach out to us if you have any direct questions to Mark or Lynette, and we're very happy to forward those and answer those as well. Just a reminder that this is just the first one out of the series. So if you haven't already, please subscribe, and we'd love to see you as we delve deeper into each industry. But if we don't have any more questions, I see quite a few people have been logging off because of the time commitment. We want to thank you so very much, especially to Mark and Lynette for being here with us today. And thank you for joining us here as well. And I hope you all have an excellent rest of the day. Look forward to seeing you in the next webinar, and thank you very much again to Mark and Lynette.
Thanks a lot. Thanks, Josefine. Bye.
Thank you.